Hello. In this video, we're going to solve quadratic equation by completing the square. Quadratic equation of the form ax squared plus bx plus c, where a, b, and c are real numbers. You can use many different methods to solve these equations. In this video, we're going to solve examples like x squared minus bx minus c, where a, which is the coefficient of x squared, is 1, and b, which is the coefficient of x, is negative 3, and the constant term c equal to negative 4. We have different steps to follow in order to solve quadratic equation by completing square. The first thing you need to do is to verify if the coefficient of x squared is greater than 1. If it's greater than 1, you need to divide each term by the coefficient of x squared. But in our example, in our case, the coefficient of x squared is only 1, so we don't need to divide each term by the coefficient of x squared. We can just go ahead and move to the next step. But the next step said when you want to solve quadratic equation by completing the square, you need to rewrite the equation so that the constant term is alone in one side of the equality symbol. So we can go and rewrite the equation as x squared minus 3x equals to 4. So we move the constant term 4 to the other side. So we add for both sides. So we have now x squared minus 3x equals 4. Now, the methods completing square tell us we need to take the coefficient of x squared, which is right here. Let me change the color so you can see. We take the coefficient of x squared, we divide it by 2, and we raise it to power 2. So negative 3 over 2, we raise it to power 2, it's equal to 9 over 4. Now, the method said we need to take half of coefficient of x and we raise it to power 2. Then we go back to our equation and add this new term to both sides of the equation. So if we want to add it to both sides of the equation, we need to write x squared minus 3x plus the new term, which is 9 over 4, equal to 4 that we already had, plus the new term. So it's like we don't add anything at all, because if we add both sides, it's like we can cancel it out. But this new term would help us to form the square of a difference. So we can have that one right here. Let me change the color so you can see. I'm looking for my cursor. Okay, right. Let me take the green one, the green color. Maybe that will be more beautiful. So now you need to think of a term right here when we do x minus is the number. When we raise it to power 2, it would be equal to x squared minus 3x plus 9 over 4. So as a hint for you, to help you think about it, if you have a minus b square, it would be a square minus 2ab plus b square. So if you have a square, a minus b square, it gives you a square minus 2ab plus b squared. If you had a plus b squared, it was going to be a squared plus 2ab plus b squared. But now, think about a number. I already tell you about x squared. So if I want x squared, I need to write only x. Now, if I want to have 9 over 4, what number should I subtract from x squared in order when I raise that number to power 4, it would be it's to power 2, it would be 9 over 4. So I guess you think about it already, it would be 3 over 2. And in this side, we have common denominator for the constant term here. You know, we have 1 right here. So common denominator would be 4. 4 times 4 is 16 plus 9. We're going to have 25 over 4. So if I remove, we can work in this side right here. If I work here, let's say for now, we can take the square roots of both sides. If we take the square roots of both sides, we're going to have right here, the square roots of this side and square root of the right side, and it should make it x squared x minus 3 over 2 equals to plus and minus 5 over 2. If I move the 3 half in the to the right side, so I need to add 3 half both sides plus 3 half. Then our solution, we're going to have two solutions where we have x equal negative plus and minus 5x over 2 plus 3 over 2. So as you can see, because when we take the square roots of 25 over 4, it give us two real numbers. So 5 over 2 and negative 5 over 2. So that's what help us to have two solutions. The first one would be x equal 5 over 2 plus 3 over 2, and it would be 8 over 2, which is 4. And then we have a second solution that would be negative 5 over 2 plus 3 over 2. This would be negative 2 over 2 would be negative 1. So if you go back to the equations and you try to replace x by 4, as you can see, it will be 4 square if you go back and you try to replace x by 4. You will have x square here, so 4 square, that would be 16. If you have replace x by 4 here, 3 times 4 is 12, so negative 12, negative 4, negative 16. 16 minus 16 is 0. So 4 is the solution to this equation. If you replace x by negative 1, negative 1 power 2 is 1. 3 times negative 1 is negative 3, and you already have a negative here, so it will be 1 plus 3 is 4. 4 minus 4 is 0. So both answers are verifying the equation. So the solution to this quadratic equation would be 1 and negative 4. So we solve this equation by completing the square. Remember, you could use other methods like factoring uh, this trinomial that could be x minus 4 and x plus 1. You could do that also, or you could use only the quadratic formula where we can say x equal minus b plus and minus square root of b square minus 4ac over 2a. So solving quadratic equation by computing the square is important because this method is very useful for some applications, including analyzing the graph of a parabola or developing general formula for solving quadratic equations. Lately, we use it a lot also by uh, for equation of a circle. So I hope it was useful to you, and then I ask you to keep subscribing to my channel for more videos. So hope you enjoyed this one, and until next.